Hello, this is demo video on running the board without the debugger in real time. Based on the requirement, if you press on the button for 1 second, then the red light will blink, the red LED, and then the system will be reinitialized. And after, for the design of a program, after you initialize the system, you actually start erasing the memory and write it. And also, after that, if you do not doing anything, every minute you will erase and write a new memory to new data into the fresh memory again, over again. Yep. And for the further CCS debugger demo video, will be in the part 2 video. Hello, this is the demo video for the CCS debugger. This is my code I wrote for the challenge assignment 1. First, this part will be the one I initialize the ports of the like buttons, LEDs, and here is the one I stop the watchdog timer first, and after do the blink the red light, and I resume the watchdog timer. And with the test 4, that will be setting the watchdog timer, the timeout to be around like 1 second. And this one is the one I set up the wait state for the memory. And I'm using the running for the while loop instead of while one, so they will be making more sense when I was reviewing the code. And the time count is the one I used for doing the to allowing the system to rewrite fresh memory every minute. And here is the one to initialize the watchdog timer. So so doing running on this, so every time if the user not clicking on the buttons, like here the while loop here, if you user clicking on the button, holding on it, you're stick in the while loop, so the watchdog timer will not get reinitialized. So once you hold on it for over a second, the watchdog timer interrupt will occur, and then the system will get reset. In the if loop is the one where every time because I set it up the first time, the first value of time coverage is way higher than this one, which means every time the system for the first time to run, the program will actually erase and write the main memory. And also for this value, I found out that when the counter getting this value will be roughly need to 1 minute to reach, which means every 1 minute the program will erase and write a memory. In this one, the way I protect all the sectors of the memory that I'm gonna use at once. Since the second parameters of the functions is the bit mask selector, so I could definitely easily to use the bitwise OR to OR all the selector bits, bit masks together, so I can minimize this statement into the one. And then this is the one I create a buffer for 4 kilobytes for the to store the value that I'm going to store into the main memory. And before I actually write it into a memory, this one is erasing memory. I have to erase first. So I set the start location to be the address I'm gonna start on it, and then using for loop to iterate 32 times. So 4 kilobytes times 32, and then that will be 128 KB. So while I'm running on it, erasing it, and then after erasing it, I will start running the buffer into the location that I just erased. And once I finish everything, and then I will re-enable the protect of the sectors. So I'm using this one and also the same technique that or all the selectors together. After I finish everything, I will blink the green light for 1 second to indicate that the process has completed. And after everything I finished, I will re-enable the watchdog timeout. And this function is the one I use for delay 1 second for the LED blinking stuff, such as blinking the green light or blinking the red LEDs. And now I'm going to run the program and to show how the memory was actually being erased and rewrite. So when running on it, So now it's finished. So if I look into the location, such as 20, you'll see the starting point that I was going to write on, it all turn into the value that I want to assign for. And they will keep going until to the last bits of the main memory, which is 34444. And you can see that is also the value that I just assigned. Yep. And once I close this one, and I think that's it.